Hello, welcome back to the YouTube channel of MAFA, that's the Mathematics Academy for Africa. So today we are going to deal with part 3, that's question 25 to question 35. So the last 10 questions of what we started answering recently, I'm talking about that's Littoral Mock 2022 paper 1. We were answering the first 35 questions. You can view the description below to see the link for the first two parts of this same solution. So let's go directly. So here we have question 25, which says the volume of the solid generated when the region bounded by the curve y is equal to e to negative x is underlined x0, x is 1, is rotated completely about the x-axis e. So here we need to find the volume generated when a curve is rotated about the x-axis. The formula, we know that the formula is v is equal to pi integral of the boundary values. The boundaries here are 0 and 1, so you're having 0, 1, y square, y, but here is equal to e to the negative x, then y square dx. This is because we are on the, they said that it is bounded about the x-axis. So here we are having this v is equal to pi negative, integrating e to the negative x or that square, same as integrating e to the negative 2x, because by indices this is the same thing as e to the negative 2x. So when you differentiate e to the negative 2x, you're having negative 1 on 2. So you just play with this. You are going to have this as the integral. You integrate this from this, you are having this. Yes, so v is equal to, you bring this a half, this is a constant, so it can be moved out, so you're having negative pi on 2 into 1 over, if you put 1 here, you're having e to the, because you're having upper limit minus lower limit, so upper limit here is what, e to the negative 2 into 1, that is e to the negative 2, that's 1 over e square minus 0, 1. So if you bring this negative in here, you're just having v is equal to pi on 2 into 1 minus e to the negative 2. Remember that 1 over e squared is the same thing as e to the negative 2. So if you just compare the directly, you are going to see the answer is B. Going to the next question, which is question 26. Which is the general solution. The general solution of the differential equation, that is, we need to find the general solution of that differential equation. The first thing you have to know is, we see, first identify, is it a variable separable or not. So you clearly see that it is just a direct variable separable. So when you say variable separable, you mean that all things containing a variable should be on one side, and all things containing other variable should be on the other side. As you are seeing here, it has been separated because all having v is on the left and all having t is on the right. So integrating 1 over v plus 1 dv, this is just ln of our answer, because when you differentiate this, you're having 1, and then on the numerator you're having 1, so you can integrate by recognition, which is going to have ln v plus 1 plus, you do the same thing here, which is just you differentiate having 1, you differentiate 1, so recognition ln c plus ln k. This ln k is just a constant. I just took ln k because it'll be easier for us to work with ln k. So you're having ln k plus 1 is equal to ln kt. This is because ln a plus ln b is equal to ln ab. So that's, you just multiply, and then taking exponential of both sides, you're going to get v plus 1 is equal to kt, because exponential of ln a is equal to a. So this is v plus 1 and then kt. I mean v is equal to kt minus 1. Answer B. Moving to question 27, it says, given that z is a complex number such that aggregate of z plus 1 minus I is equal to 5 pi on 4. The locus of the set of points where z is, so we need to find the locus of the set of points. Okay, we're having this to be 5 pi on 4, so we just let z to be a particular x plus yi, where x is our imaginary part and then yi is the imaginary part. So is a what? So boom, here x is the real part and then yi is the imaginary part, because we are having the one on the I here. So tan inverse here is just the same thing as the y part, the imaginary part, as y minus a 1 here. So since z is x plus yi, so you just replace it here, having y, that's the imaginary part, and then a negative 1 here, y minus 1, yes, divided by the real part, which is the real part of z, which is x, plus this one is also real because there's no I attached to it, so you're having x plus I is equals to 5 pi on 4. That's considering that x and y are positive real numbers, because there are many other conditions for the aggregate to be, for the argument to, there are many other conditions for the argument to be, to not to be like that or to be like that. We are going to do a video for it. If you would like to see a video for that, just leave a comment and don't forget to like and subscribe. So since we have this, so taking tan of both sides, you're having y minus 1 all over x plus 1 is equals to 1, because taking tan of both sides, you're just, this tan is going to go, and then you're having tan this, which is 1. So you're having, from here you cross multiply, you're having y minus 1 is equals to x minus x plus 1. 0 is equals to x minus y plus 2. So the answer here is C. Just see directly, yeah, because if you take, if you take it on the, you must also by negative, you are going to have this. So just try and you see, you must have it. If you don't have it, then you need to verify your signs. Question 29, it says I to the negative 99 is equals to, so you just need to simplify that and find the value. Let us, we know that I to the negative 99 is the same as I to the negative 100 plus 1. Since one's a negative 100 plus 1 is the negative 99. So there is same thing as I times I to the negative 100. But I to the negative 100 is equals to I to the power 4 times a negative 25. But I to the power 4 is 1. And due to this negative, due to this negative, having 1 all over 1, I to the power 4 is 1, because I to the power 4 is I squared times I squared, but I squared is negative 1. So negative 1 times negative 1, which is positive 1. Positive 1 to the power negative 25, that's 1 over 1 to the power 25, which is 1. I to the negative 99 is equals to I dot 1 is equals to I dot 1, because here we said it was I dot I to the negative 100, but I to the negative 100 is equals to 1. So having I dot 1 is equals to I. So the answer here is D. Question 29. The quadratic equation with 2 minus I as one of its root is, if we know that 2 minus I is a root, then its conjugate 2 plus I is another root. For every equation, it's always like that. If you have a complex number to be a root, then the conjugate of that complex number is another root of the same equation. So here you just go directly by x squared minus sum of root times x plus product of root is equals to 0. Sum of root here is 2 minus I plus 2 plus I, which is 2 negative are going to go, you're having 4. Product of root, you having minus 2 minus I into 2 plus I. This difference of 2 squares, you this one square 4, and then this one square. Don't forget that I square is already negative 1. Negative 1 times this negative, that's positive, having 5. You just replace in your formula, you're having your answer directly to be D. Moving to question 30. Which of the following does not respect the equation of a circle? Okay, this is the simplest question on this paper if you know the formula. And the formula, let us discover it together. No, you are the ones discovering, because me, I did it already. So the equation of a circle at center A, B is of the form x squared plus y squared minus 2ax minus 2by minus c is equals to 0. AB is the center. So A is the x coordinate of the center and B is the y coordinate of the center. And then what is C? If you know what this C is, leave the formula in the comment section so that let us see together if what I think it is also what you think it is. The answer here, if you just compare directly, you are just seeing that the answer is obviously D. Obviously. Okay, the next question. So yeah, you are just left with 4 questions to finish this. Oh, this is the cosine of the acute angle between the line y minus 2x plus 5 is equals to 0 and y minus x plus 6 is equals to 0 is, we need to find the cosine of that acute angle. Okay, those are the lines given to us, but to find the cosine angle we need to find the gradient the first thing we need to come out here is the gradient. Here, to find the gradient, you just have to put in the form y is equals to mx plus c. If you put this in this form, you are just going to see that this 2x is going to go the other side. It's not like it's going the other side, but actually you're adding 2x minus 5 on every side to get y is equals to 2x minus 5. We do same with this side, so you're having that the gradients will be this first one, m1 is equals to 2, the second one, m2 is equals to 1. Try and have it. So but we know that tan theta is equals to gradient 2 minus gradient 1 all over 1 plus gradient 2 gradient 1. That's 2 minus 1. That absolute value of this, if you take m1 minus m2, will not change anything, because I think the absolute value of your answer, you're having 2 minus 1 over 1 plus 1, that's 1 over 3, 1/3. Tan theta is 1/3, plus cos theta is equals to 3 on 10. How did I get it? Using a Pascal's triangle. Is it? No, it's a Pythagorean triangle. Pascal's triangle is just that thing of binomial expansion. 1 1 1 2 1. For those who know, if you don't know, try to get to us to find more about it. So the answer here is A. That's question 32. It says the perpendicular distance between the planes r dot 2i plus 2j plus k is equals to 6 and r dot 2i plus 2j plus k is equals to 10 is, we need to find a perpendicular distance between two planes. Let us see how we are going to proceed with this. Okay, moving, that's we are giving these two planes. If you look attentively, you are going to see that their numbers are equal, because the equation is like r dot n is equals to a dot n. R dot n is equals to a dot n. A dot n here get us 6 and a dot n here get us 10. Remember that it's not the same plane, but two different planes. So they can have the same number if they are like perpendicular. That means one is placed over the other. And then if the numbers are equal, let us find the magnitude of the number. The magnitude is, that's, to find the magnitude, you take the number is 2 square plus 2 square plus 1 square. Just take the square root of all of it, that's 3. We are having d, that's the distance between the two planes. The two planes is given by the, you take the absolute value of d of this minus this, or you can also take this minus this, so you give the same answer. That's 10 minus 6 all over 3. That's the absolute, the magnitude of the normal is 4 on 3. Answer that's falling from A. A? Yes, A. Question number 33 says the Cartesian equation of the line is given by x minus 1 all over 2 minus is equals to 1 over y all over negative 2 is equals to 3 minus y over negative 1. The solution is pretty simple, because that's a line given to us. If you notice where, you are going to see that there is a negative down here, and then these sides have been inverted. There is also a negative down here, and then these ones have also been inverted. So you just see that if we remove this negative, yeah, this one is y is going to be y minus 1, and then if you remove this, it's going to be z minus 3. So from here you can come up with the equation of the original line, that is 1 because there was already this negative here. If it comes here, 1 minus 1, y minus 1 over 2, that's 1. Same thing here, the one here is 3, so you're having 3k plus lambda into 2i plus 2j plus k, that's 2i plus, since it is negative, if you do what we have been talking about, having 2j, same thing here, k. So the directions ratio are just the individual values here of each unit vector here. So you're having 2 for the I direction, 2 for the j direction, and 1 for the k direction. So the answer is D. The question number 34. The values of y corresponding to the values of x are given on the table below. Use the trapezium rule to approximate the value of integral from 6 to 21 of y dx. So when y is 6, 0.39, 0.8, this is what you are seeing there. Okay, moving question 35. That's the solution to question 34 person. So we are having this integral that we need to find. H is 3 because from here to here we are having 3, here to here 3, here to here 3, here to here 3, here to here 3. Okay, so we are having that integral from 6 to 21 of y dx equals to h all over 2, that's 3 all over 2 into sum of n's, That's the end here. We're having 0.3 plus 4.3 plus 2 sum of the rest. That's the trapezoid rule. Sum of n plus 2 sum of the rest. You're having sum of n here plus 2 into sum of this plus this plus this plus this, sum of the rest. Yes, so you're having that this integral from 6 to 21 of y dx is approximately 28.8, because we are approximating. It's not like this is the exact value, you just approximate to the value. The answer is D. Moving to question 35, that's the last question of this we are touching. Yeah, so we are having the polynomial f of x equals x cubed minus 2x squared plus kx plus 2 as a root in the interval 0 less than x less than 1. The range of values of k is, okay, if you have a root in this interval, you're having this equation. If you have a root in that interval, it simply means that f of 0 dot f of 1 is less than 0. That's the condition for each to have a root in the interval 0, 1. For everything, like for in the interval a, b, f of a dot f b is less than 0. Being less than 0 means you have a negative sign. Yes. So f of 0 is 2, f of 1 is k plus 1. But you know that the product is less than 0, so 2 times k plus 1 is less than 0. If you divide both sides by 2, you are not changing anything. You are having k plus 1 is less than 0, implies k is less than negative 1. The answer is B. Thank you for watching this video. If you have any proposal, any questions you like us to have a solution, you have to like the solution, or any other proposal to improve our YouTube channel, don't forget to get to us via the comment section. We are answering to all the comments we receive, and thank you for watching this particular solution, and see you next time. Don't forget to like, share, subscribe, and all the rest.